Go over 4 rules with respect to drawing curved arrows. So it's important to appreciate that multi-step reaction mechanisms can sometimes just be a combination, right, of the 4 patterns that we've described thus far. For example, as we have here, let me get my red marker out. As we have here, if you were told that this was the mechanism for a particular reaction, you would go, oh, okay, I see. So you've got, if you knew, suppose you didn't know this arrow was here, but you knew that this water was formed as a leaving group, right? You would say, well, I've got an acid here, and here's my base, so boom, yep, I got that. This is proton transfer, right? Here's kind of like a leaving group or proton transfer. It's kind of both the same thing. And you've got your water, right? So water leaves. Aha, I see water leaves. Therefore, this must be going here. Boom. Let me redraw the arrow. The arrow actually goes to the oxygen, right? Because that lone pair ends up on the oxygen. Fair? Then it looks like I've got if you had this, if you didn't have this mechanism, but you saw that you had a carbocation here that was secondary, then you had a tertiary carbocation, you would say, oh, what happened was one of these methyls moved over. So I had a 1,2 methide shift, right? So you're going to be doing this a lot. So get used to these. You've got a proton transfer, you've got a leaving group, carbocation rearrangement, and a nucleophilic attack. This is a mechanism which comes from, well, I guess here in Organic 1, but it's amazing how if you get used to these 4 things, you really set yourself up for success. Often 2 of the patterns occur in a single mechanistic step. So here I've got a nucleophile, right? There's my lone pair of electrons. Boom. Redraw my arrow. Lone pair of electrons, boom, and then a leaving group, right? So a nucleophilic attack and the loss of a leaving group happen at the same time. All right, so let's look at 4 rules that you need to appreciate as you're drawing curved arrows. Number 1, the curved arrow starts on a pair of electrons. As we've said before, it starts on a pair of electrons, which is either a shared pair in a pi bond or a lone pair. Okay, so it starts on a pair of electrons, and then this is just a side point. This is drawn incorrectly. We should start it on a lone pair here, right? We've got the lone pair here. Goes on a lone pair, but it goes here. This is drawn incorrectly because it ends on an atom. Watch this. Okay? So the lone pair goes here, boom, goes here to a carbon, and then this leaving group ends on the atom itself. Okay? And those are they, right? Those electrons are these electrons over here. So number 2, the head of the curved arrow shows either the formation of a bond or the formation of a lone pair, right? It either shows the formation of a bond or a lone pair. Rule number 3, the head of a curved arrow can never show carbon forming more than 4 bonds. So this is not correct. It's the start of a correct mechanism, but it's not correct because you cannot have 5 bonds to a carbon. So here, this carbon, this lone pair, man, my arrows are horrible today. This lone pair goes to that carbon, and this leaving group leaves, right? Then if they happen simultaneously, then you go, yeah, I still only have 4 bonds here. And then finally, rule number 4, any curved arrow should describe only one of the 4 patterns that we've described thus far. Either nucleophilic attack, loss of a leaving group, proton transfer, or rearrangement. Okay? If you can't put it in one of those 4 boxes, it's certainly wrong. All right, so go practice drawing curved arrows.